Alright, in the last video, we looked at why we call the intersection of our perpendicular bisectors the circumcenter. It's the center of the circle that circumnavigates the triangle and touches each triangle exactly on its corner. Okay? And then we reviewed how to remember which type of ray or segment or line we're looking at in a figure. Okay? So now we're going to apply the properties of circumcenters to triangles. Okay? So my perpendicular bisectors of the triangle here below are drawn and intersect at the circumcenter P. And it's kind of hard to tell, but P is this circumcenter right here. So this is my circumcenter. It says my perpendicular bisectors are drawn. So that means I see where I have my perpendiculars. That means it's dividing these segments into equal pieces. And then here. Because these are my perpendicular bisectors, the one that comes from the 90. Okay? This means that when I look at this figure, since I know that this P right here is my circumcenter, that means it's the center of the circle that if I could draw not an oval, and if my picture was to scale, it's the circle that would touch each corner exactly. Okay, so it would touch here, it would touch here, and it would touch here. Okay? So, then when it asks me, it says AP is 3x plus 9. So the distance, remember I know the P is here, but P is really here. So AP, this distance is 3x plus 9. And CP is 51. CP is 51. These two pieces both go and touch the circle that goes around the triangle. So remember when we talked about the incenter, and we talked about if you have a segment that starts at the center of a circle and it touches the circle, we call that a radius, and all the radii, also a little bit blurry, all the radii in a circle are exactly the same. So whatever one is, the other one's going to be exactly the same. All the radii that we could draw in there. So since this is a radius of the circle, and this is a radius of the circle, we know that these two pieces are going to equal each other, as well as this third one here that goes to the corner. All three of these will be equal, because they are all the radii of that circle that goes around my figure. Okay, so that means this 3x plus 9 is going to equal 51. And that we can solve. We'll do our subtraction property of equality. 3x plus 0 is 3x. And 51 minus 9 is 42. We'll divide both sides by 3, my division property of equality. And x equals 42 divided by 3 is 14. Okay? When I look at the next figure, point O is the circumcenter of triangle RTS. So they're already telling me this is the circumcenter, which means I know that if I have the circle around it, the distance to the corners are all radii. So this 5 here, and I already have a single tick mark, so I have a single, double, and a triple. So really I should put 4. This piece here that's 5 is going to match this piece here, so it's also going to be 5. And it's going to match the corner to the corner here, so that's also going to be 5. Okay? When I look, it says segment RO is congruent to. So remember when we have a segment and a congruent to, they're looking for what other segment does it match. So R to O that I said was 5, it matches the other two that go to the corner. So it matches R to O, matches T to O, and it also matches S to O. Those are all going to be congruent because they're all the radii of the circle that goes around this figure. Okay? So then when I have just the letters without the bar and an equals, that's when I'm looking for the actual numbers. How long is that piece? Well, R to O, we already said it has to match T to O, so they're both 5. Okay? The next one is asking me how long is it from R to T? So from R all the way to T. This one we have to do a couple little things. Okay, the first thing we're going to do is we're going to say, well, I know this is a midpoint, so if I can find one side of this, then I'll know to double it will give me the whole thing. Okay, now notice I have a little right triangle here. If I look at this piece here, I'm going to kind of shade it in a little bit. This is a right triangle where I know one side is 5 and one side is 3. If I were to resketch that right triangle right over here, where I've got a 3 here and a 5 here, and I'm looking for whatever this value is here, I can use the Pythagorean theorem, because a squared plus b squared will equal my hypotenuse squared. The one across from the right angle always goes to the other side of the equals. So x squared plus 3 squared is going to equal 5 squared. X squared plus 3 squared, that's 9, equals 5 squared, that's 25. I'm going to subtract 9 on both sides, and I get x squared equals 16. And again, to get rid of that square, we unsquare or square root. The square and the square root cancel, leaving me with just x. And the square root of 16 is 4. So that means this piece here is 4, which means this piece here is 4. And the whole length then is 8 for the distance from R to T. Okay, and then the last one it wants to know here is the distance from R to S. So I'm going to kind of do the same exact thing. From R to S, if I can find one side, then I can double it to know the whole thing. So now I'm going to look at this triangle here, and when I look at that triangle, I know the hypotenuse is 5 because that's across from my right angle. I know this little piece here is 1, and I'm trying to I already used an x up there, so I'm going to call this one y. So I'm trying to find this piece here y. All right, so across from the hypotenuse is 5, so that goes on the end. I'm going to have 1 squared, or y squared, you can start either place, plus 1 squared is going to equal 5 squared. Y squared plus 1 times 1 and 5 times 5. I'm going to subtract 1 on both sides. Y squared equals 24. And then to unsquare, I'm going to square root. And y is going to equal, that's going to turn out to be a decimal. It's okay, I'll round it to 3 places. It's going to be 4.8, when I round correctly, 99. Okay? All right, so now all I have to do then is just double that, right? Because if this is 4.899, that means this side is 4.899. So when I double that, I end up with a whole side that is 9.798. So the distance from R to S is 9.798. And we don't know any of the units on these. They didn't give me any units, so I could just write 9.798 units, 8 units, and 5 units. It's always nice to include your units. All right? In the next video, we're going to look at what happens when you have a point on a perpendicular bisector of a line, and then what kind of triangle you can expect to see when that happens. Okay? Thanks for watching.